In this lab, we are going to see the program for implementing Ackermann's function using recursive functions. First, we will see what is an Ackermann function. It is an example for a recursive function. This function is going to take two arguments, and each of the arguments can be assigned to any non-negative integer, and the function will be applying the concept of recursion and finally will arrive at a particular value. So this function will take two arguments m and n, and based upon the value of m and n, we will have different cases. So here there is one case known as base case. The base case is mainly used to stop the recursive call, and here this is reached if m is equal to 0. So in that case, the function is going to return n plus 1 as a value. There are two general cases. One general case is if m is greater than 0 and n is equal to 0. So in this case, the value of the function will be nothing but it is obtained through a recursive call where we are going to pass two arguments. One is m minus 1 and the other is 1. So we are going to call the same function a by passing m minus 1 and 1. Then the another general case is if m is greater than 0 and n is greater than 0. So in this case, we are going to call the function a by passing two arguments. One argument is m minus 1 and the other argument is another recursive call where we will be passing two arguments m and n minus 1. So in every call, when we are starting with two arguments m and n, and in any recursive call, the size will be reduced. So from m, it is reducing to m minus 1. Finally, we will arrive at a case where m is equal to 0. In that case, it will be returning a value of n plus 1. So that will be returned to the function where it has been called. Now let us see one example. I'm going to call a of 1 comma 2. So here m is 1 and n is 2. First, we have to see for which case this call will be going. So m and n both are greater than 0. So it will go to the third case. So in this, we are going to call a of m minus 1 comma a of m comma n minus 1. So first argument is m minus 1. M is 1. So I'll be passing 0. Then second argument is a of m comma n minus 1. M is 1 and n is 2. So n minus 1 is 1. Now, if we see out of these two, the second argument is another recursive call. So we have to now replace a of 1 comma 1 by the recursive call. So now let us evaluate the value of a of 1 comma 1. So in this, both m and n are 1, which is greater than 0. So it will again go to this case. So we are going to evaluate a of m minus 1. So m is 1. So we have 0 now. Then second argument is a of m comma n minus 1. So a of m is 1, n is 1, so n minus 1 is 0. Now again, the innermost one is a recursive call. So we have to evaluate this. So we need to call a of 1 comma 0. So in this, the second argument n is 0. If n is 0, so we need to go for this particular case. We need to call by a of m minus 1 comma 1. So m is 1. M minus 1 is 0, then second argument is 1. Now in this case, the first argument m is 0. So when this function is called again, we will have n plus 1 as a return value. So here n is 1, this will return 2. That 2 will be returned to this particular place. So now this is replaced by a of 0 comma 2. Now in this case again m is 0. So again control will come here. This is the base case. N plus 1 will be returned. So n plus 1 is n is 2, n plus 1 is 3. Now we have a of 0 comma 3. Again m is 0. So now this will return n plus 1. So n is 3, n plus 1 is 4. Now let us see the program for this Ackermann's function. So in the program, first I am writing the main function. In the main function, I need to read the value of m and n. Finally, I'll be calling the Ackermann's function, which will return me the answer that I am storing in the variable result. So first from the user, I am reading the value of m and n. And then I'm calling the Ackermann's function by passing the value of m and n. So now control will go from this line to the Ackermann's function. Since I am passing two values, I am going to receive the two values and store it in the variables m and n. Now we have to write all the three cases one by one. First, I will be writing the base case. If m is equal to 0, the function will be returning n plus 1. Then the control will go back to the place where it has been called. Otherwise, if this condition is false, we have to check whether m is greater than 0 and n is equal to 0. So here we are using logical AND operator. So this will evaluate to true when both the information are evaluating to true. So when both these conditions are true, we will be getting true. So in that case, this will be calling Ackermann of m minus 1 comma 1. Else, if both these conditions are false, the control will come to the next if statement. So here we are checking whether m is greater than 0 and n is greater than 0. In that case, we are going to call the function by passing m minus 1 comma Ackermann of m comma n minus 1. So this function will be returning a value after it has given the control to the recursive call. So finally we will be getting the answer. That answer will be returned to the main function. We'll be storing it in the variable result. Then we are printing the value of the result. Now let me run this program. When I run this program by entering the values of m and n as 1 and 2, I am getting the answer as 4, which we have seen in the previous example.